between the blower and the mechanism, if you have the automatic, and you pull the collar back, put it down onto the post, and pull the collar down to lock it into place. So it won't come off, but it will still swivel. Plugs into this outlet right here, which when the machine is plugged into the wall has power all the time, so the light can be turned on and off at will. To install the disc, you'll be lining up the hold down screw hole in the disc with the threaded hole in the drive plate. Make sure that the pin in the center and the reference ring surface are both clean and free of any grit particles. Wipe out the center hole in the disc and also the reference ring on the underside of the plate. Line up the hole with the threaded hole and slide it down over the motor shaft. Install the drive hold down screw and tighten securely. Before you tighten it completely, you want to push the disc towards, with the screw towards you, push the disc away from you to take up any minute amount of play in the center. That's how all the machining and balancing operations are done, and we want to duplicate that when we install it on the machine. At this point, you can draw the guide wire across and attach it to the post. It has two posts for the different size blades. You'll be using this post all the way up through the number 4 blades, and all the taller blades you can put it on this post so that you have more clearance when you're doing the blades. If you need to stop the disc, you'll employ the brake simply by pushing on the black knob so it contacts the edge of the disc and slows it down. The lapping disc creates a hollow grind in the clipper blades. I'll do a quick explanation of what I mean by that. If the disc was machined perfectly flat, it would create a flat grind on the blades. In other words, the bottom of the blade would be ground flat, which would result in complete tooth contact when mated up against the other blade half. What's advantageous is to hollow grind the blade so that you have pressure at the absolute tips of the teeth for better cutting action and more life. And the way that is achieved is by the way the disc is machined at a slight angle, and that'll make for contact at the tips and the back of the back rail on the blades. If you draw a line across the center of the wheel, that represents the crest of the crown of the wheel. The disc is machined at a slight angle, which is like a cone being almost flattened out. It is machined perfectly straight in line with center line. As you can see, when the straight edge is on the disc surface in line with center line, it is absolutely straight. And that's very important, and that is where the accuracy comes into play. And as the disc wears, when you get out of tolerance, that's when the disc needs to be resurfaced. This has to be perfectly straight and flat in this direction so that you get an even straight grind on the blades for equal tooth contact. The other direction, however, is what creates the hollow grind. As you can see, when you go 90 degrees to center line, you can see a space on each side of the ruler, and I can actually rock it. And that represents the crown of the wheel. So when the blades are sharpened, you're always wanting to stay parallel to that center line and centered, having the blade centered over that center line. So the high point of the hollow grind is in the center of the blade in relation to where the cutter rides. So you would center the cutter over the center line in the grinding process, and in turn locate the comb blade over center line in relation to where the cutter blade is going to mate up to it when it's assembled, so that both halves of the blade have been sharpened on the wheel in the same point in relation to center line. When you do that and you achieve a uniform hollow grind with equal tooth contact all the way across, then the blade is going to cut like it should and last as long as it can. The guide wire is used as a guide in the sharpening to stay parallel to that center line when hand sharpening. So as you're on the disc going back and forth, you've located the center. You reference the proper distance back from the string line so you're still on center line, and as you stroke back and forth right to left, you stay parallel. Don't twist the blade at all, don't swing in an arc, and don't go forward and back. Try to stay as close to center line and parallel as you can, and that will result in the best uniform grind. In the case of a blade set such as these Oster Stewart, you're going to center the comb in relation to where the cutter rides on it. You're not going to center it from the back of the blade to the tips of the teeth. And that's the basic principle you can apply to all blades that you sharpen. After a blade has been sharpened, we want to determine that in fact the profile of the disc has been accurately ground into the blade, and that we have in fact achieved equal tooth contact. And that is what the test plate does. The test plate is a known value. It is ground flat, perfectly flat. And the blade that we've ground is an unknown. We've hollow ground it, but we want to know in fact that we have equal contact at all the tips of the teeth and at the back rail by rubbing it on a flat known surface. So the test plate is that flat known value, and the blade is the hollow ground unknown, and we want to determine how uniform we ground the hollow into the blade by how well we controlled it on the plate. How, if the plate is worn out of tolerance or not, is going to show up on the blade. So with the blade perfectly clean and dry of the grinding grit and the rubbing block perfectly clean and dry, I'm going to put equal pressure on the blade, about a pound of pressure or so, and go in a figure-8 pattern. This is going to burnish the high points of the blade, which should be the tips of all the teeth and the back rail. So once I've done that, I'm going to look in the light and I'm going to look for contact all the way across the tips of all the teeth and equally down all the teeth. and also the back of the back rail. And that is how you determine that you've controlled the blade properly and your disc is still within tolerance. If you do that to each and every blade, then you're assured that you're not going to be handing out any bad blades. Besides achieving a uniform hollow grind, the other important element to sharpening the blades is to grind enough material off to get them fully sharp. A sharp blade, such as this cutter, comes to a very sharp point at the tips. After use and being dulled, the tip is slightly rounded, and also the cutting edge down the flute of the tooth has a dull radius. When sharpening the blade, we need to grind into the body of the blade and remove enough material to get past that dull radius and achieve a sharp cutting edge and a sharp point. This is usually 1/1000th, 1/1000th and a half on an average on the standard A5 blades. You will, however, achieve a complete grind on the bottom of the blade by only taking 1 or 2/10ths of 1/1000th off. Now, you don't want to be fooled that you have sharpened the blade at that point just because you've achieved a complete grind on the bottom of the blade. You must closely inspect the tips of the cutters under magnification to make sure you've gotten past the dull radius and in fact have gotten the blade fully sharp. The only way to test that is to visually inspect them. The test plate does not tell you when the blade is sharp. It just tells you if you've achieved a uniform hollow grind. The guide wire has 2 posts that it can be connected to. The first post is for all the blades that do not have real long teeth on the comb blades, and you're going to reference to center line to determine how far away from the string you should be. Then you're going to duplicate that distance when you're down on the plate sharpening. With a large blade such as this tall 3/4, where you would be running into the guide wire if it was on the first post, you move to the second post, take your reading, and that's where you're going to be as your hand sharpening. If you're using the automatic machine, you don't need the guide wire for guidance, but you can move it over there so it's not contacted from the blades and possibly knocking the taller blades off. Steps in the sharpening process. We're trying to achieve a uniform coating of the lapping solution on the disc surface to hold a very uniform and light coating of grit so that each particle is impacted equally by the steel blade as the wheel is rotating, and the particles are driven into the soft aluminum to become slightly lodged and become fixed so that they're not sliding and grinding the disc instead of the blade. So the principle is, by using the softer aluminum, that the particles become lodged and fixed and remove steel off of the blade. So I'll go through the process with the lid of the machine off just so you can see it a little better, but then I will do it with the lid on, because all of our recharging tools and cleaning tools are designed to be used through the opening of the lid to have the process be as clean as possible. So with the disc dry and clean, I'm going to put a measured amount of the lapping solution onto the surface. I'm going to have the disc spinning slowly, so I'm not going to be slinging it off yet fast enough to where I can drag the eyedropper pipette across without taking too long. So I'm going to put about a milliliter of solution in the pipette, starting in the center. I'm just going to drag it across, and if the wheel is going too slow, I can just bump the switch. And you're trying to get as uniform and tight together lines as you can. Then with the applicator pads, I'm going to start from the outside and push the fluid in, so I don't just push it off the outer edge of the wheel, and smear it out so I got the surface completely wet. And I'm going to bump the motor to slightly speed it up, and I'm working it so it's drying and becoming somewhat tacky. And when I feel that it's starting to want to pull the applicator on my hand, then I know it's getting tacky, and I feel an even pull all the way across. At that point, I've got a uniform thin film, and if you stop the disc and take a look at it, you shouldn't be able to really see any dark streaks or bands, and when you put your finger in it, you should just be able to see your fingerprint there. The next step is to apply a light coat of grit, and we do that with the grit spreader. I'm going to fill the hopper of the spreader with grit out of the bottle, and this will do multiple recharges. Just kind of level it out by shaking it there. And to operate the grit spreader, you're going to be squeezing the handle to close the contacts to activate the vibratory motor, and it'll shake an even sheet of grit off the edge of the pan. Now the rate of the grit coming off is going to be determined by how far forward and back you tip the pan. So you want to tip it back so nothing's coming off, and just bring it slightly forward, and just forward enough to where you're getting a sheet of grit off the width of the pan, but as light as possible. Now we're going to be trying to dispense about 1/8 of a teaspoon of grit onto the surface of the disc. And you can practice using the grit spreader over a piece of paper to get a feel for how the grit comes off. But if you dispense grit at a certain rate for a certain length of time consistently, then you can practice over a piece of paper and measure how much you're actually dispensing onto the disc. So in that length of time, you can pour it back into your measuring spoon to see how much you're actually putting onto the disc. And that was, approximately 1/8 of a teaspoon. So you want to get at least 1/8 of a teaspoon, maybe a little more. Depends, on how fast the disc is going, if all of the grit you're dispensing is in fact landing on the plate or not. But you want to get about 1/8 of a teaspoon on the lapping band. So we're going to have the disc spinning fairly slowly. We want it as fast as we can get away with, but if it's too fast, there'll be too much air turbulence and the grit won't land on the surface of the disc. So I'm just going to hold this over the band, and I'm going to slightly move it back and forth a little bit, just so I'm sure I get grit on the inner and outer edge of the disc. At this point, I can stop and look and see how even it is. And if it's uneven, where you've got bare spots or clumps, then you can rub it in with the cork block. If the grit is dispensed uniform, like it is here, then you can go directly to setting the grit with a junk comb blade, which we're going to have on the hand magnet, and we're going to go down onto the surface of the disc with the heel slightly up, and going to go over and back several times using light pressure to level it out and to start that setting of the grit into the surface of the disc. So I'm going to turn the machine on. And you should see sparking when you do this. At this point, we're ready to sharpen. So I'm going to turn this off, slow it down, and you should just see little dark spots here and there, like you've shaken some pepper on it. You don't want to see big 1/8 of an inch or larger round clumps of grit where they've collected because you had either too much solution on there or it wasn't smeared out uniform. If you had a dark band streaking, that means you didn't wipe or smear the solution out enough or uniform enough. The grit will collect where the solution is, and if there's more solution in the inner outer edge or where have you, you're going to see it at this point. So you're always wanting a uniform speckled look to the disc after the grit has been applied and the blade has been done on it. If when you use the grit spreader you happen to get an uneven dispension of the grit, such as by pulling the trigger on and off or just shaking or what have you, and you end up with piles and bare spots like I've done right there, where I've got more grit in that area and I want some more around the outer edge. You take the cork block and you can level out the charge. And I've got streaking with my solution also. So I'm going to go in kind of an elliptical rotation and just work it together. That'll help marry the grit to the solution and to the wheel. Now if you do the solution evenly and the grit dispension evenly, you can skip this step. But if you do happen to be uneven with your charge, then you can use it and not have to waste that load of grit. At this point I can stop and look at it, and if I had any real bad areas I could rub it again, or any time during the course of sharpening. If you do have heavy concentrations or bare areas, you can move the grit around with the block.
This is an example of a grit charge that is nearing exhaustion. There's areas where there's still plenty of material, but areas that are getting thin, starting to look a little smeared or streaky, and that indicates that the grit is getting broken down, dull, and starting to slide. And that's when you want to start thinking about stopping and recharging the plate so that you don't do premature wear to the disc surface. You always want to have plenty of material, spotty looking, a little dampness to it, without bare areas or sliding, streaking areas.
I'm going to clean the wheel off with the cleaning tool. I'm going to put one towel on the tool. And I'm going to wet the towel either by applying water with the squeeze bottle, or I'm going to just roll it in this on this wet sponge. Get it liberally wet. And with the disc spinning about half speed, I'm going to go down onto the disc surface and immediately start rotating the tool to remove the grit. At this point, I'm going to remove this towel, place it with a new one, and this time I'm going to wet it with denatured alcohol to dry the wheel and get rid of all the grit and debris that I missed the first time around. At this point, I have a clean disc surface and it will rapidly dry with the denatured alcohol.
Now I'll show cleaning the plate with the lid on the machine.
Have the machine running about half speed. Go down on the wheel with the tool and immediately start rotating the tool, moving it slightly side to side using light pressure, just enough to pick the grit up, but not to rub it and wear the plate. You can see you get all the debris off of the plate. Take the towel off, replace it with a new towel. This time we're going to wet it with denatured alcohol to do a final clean, and also to have the disc surface very dry for this lapping solution. You don't want any water on the disc surface when you put the lapping solution on. You can see you got the rest of the debris off. Now I'm going to leave this towel on the tool and use it for the initial cleaning next time around. So you clean the disc twice, but you only use one towel. Show the metal removal rate of the machine. I'll measure these blades before and after I sharpen them to give you an idea how much metal you're taking off when you're sharpening by hand. I'll measure the thickness of this blade. With the hand magnet on it, I'm doing about a pound of pressure on the A5 blades. So I'm going to set down heel first, stay parallel to the string line, centered over the center line, and I'll go for about 15 seconds in this demonstration to give you an idea. On a fresh charge, took 1 3/4 of a thousandth off. So that will drop down with each blade set. Centered side to side. And as I'm grinding, I'm just going to be pushing down 3/4 to a pound of pressure. Just enough to control the blade, but not so much to where I'm creating excessive heat and distorting the blade during the grinding. So you can give yourself an idea how hard you're pushing just by pushing down on a scale like this. And when I set down, I'm going to want to touch the plate with the heel of the blade first and then set the teeth down. As close to a perfect set down as I can, but I never want to set the tips down first, which will grind them away and make for the need for a lot of metal to be removed to correct it. So I'm going to go down being parallel to the string line and back about 3/16 of an inch so that I'm on center. And the minute I contact the plate, I'm going to start stroking back and forth. I'm going to go off the edge of the wheel on the outer and the inner edge about a tooth, 2 teeth at the most, so that I'm using the full lapping band. You want to stay relaxed, maintain equal pressure. And at this point I'm going to pick up with the teeth first so that I don't drag the teeth when I'm picking the blade up off the plate. This length of time I've achieved a complete grind, but I'm going to see how much metal I actually ground off. To get a blade sharp, you typically have to take 1/1000th and a half off as a starting point to get it sharp.
With the small surface area and the type of steel of this blade, we remove 2/1000ths of an inch. We've charged the plate with 180 grit for the large animal blades.
Now for these, since there's more surface area to grind away, we're going to use about 2 pounds of pressure. I'm going to hold on to it with the large blade magnet for better control. Took about half a thousand, a little better off in 20 seconds, I believe. About 3/4 of a thousand, 8/10 of a thousand on that blade in that length of time with 180 grit, using about 2 pounds of pressure. So that gives you an idea of the amount of metal that you're taking off as you're sharpening blades in that manner. After a blade set has been sharpened, you've taken enough off to get fully sharp, you've got a good rub pattern off of the test plate. You're going to want to deburr both the comb and the cutter with the bronze brush. Do that, we're going to go down away from the cutting edge. To remove the burr. At this point, we'll demagnetize the blade to help release the filings and particles, and I will wash it in solvent. A couple frames of this doing this. Set the cutter on the comb. With the socket, I'm going to take the socket tool, place it between the ears, and with a pair of pliers I'm going to squeeze the ears tightly against it to set the width of the ears and also the proper angle. I'm going to take the spring, make sure the spring guide is fully seated, and I'm just going to place it on a nice flat surface. Make sure it's not bent. If it is, I'm going to straighten it out to where I get an even pressure. Slip the socket back in the spring, put it on top of the blade set, hold on to the combination, turn it over so I can put the screws in. I'm just lightly tightening them, and now I'm going to look for the proper setback and parallel. So you're going about less than 1/16 of an inch. Depends on the blades. 40 blade you're going to have closer than a 7. You never want the tips of the cutter to be hanging over the comb to where they can damage the animal or the person who's being clipped. So I'm going to sight down it, tighten the screws up a little bit. Now the cutter will shift a little bit as you tighten the spring down. So as you're tightening, you always want to monitor everything staying straight and you're maintaining the setback. At this point, we're going to feel the force it takes to move the cutter. I'm going to oil the blade. Oil the spring guide and the rear rail. Work it back and forth. And using the socket tool, I'm going to place it on the scale and measure how much force it takes to move the cutter. And so that was about 2 3/4 pounds, which should be enough to cut. You want about 3.5 pounds on an average. There is friction involved. It will change some after you run the blade, so I may test this again after I test cut. And that's the basic operations you take to assemble the blade sets after you're done sharpening them. If you've taken enough off to get it sharp, got a good rub pattern, have adequate spring pressure, have the blade assembled nice and straight, and it passed your test string cuts and your test fur cuts, you can be pretty confident that your customer is going to be happy.
After the blades have been assembled, oiled, spring tensions checked, you'll want to test cut with both the test fur and the test string. Now you don't have to cut this much material, but you do want to go into the fur rapidly to see if the blade is going to load up. And when you're cutting the test string, what you're looking for is a nice clean cut. Whether you go through there fast or slow, you don't want the string to be splayed out, and you don't want it to leave any tails, any strands left. It should cut completely through cleanly and squarely. The amount of oil that's on the blade is going to make a difference on whether the fragments jump off the blade or not, but that's what you're wanting, is them to just explode, the nice clean cut. The adjustable blade, such as this clipper, should cut the string cleanly at all the different settings, and it should be able to go through the test fur at all the different length settings. And an extreme test is to force the clipper into the fur to where it stops the motor, and then you should be able to continue to cut. It shouldn't load up. If so, then you either have a burr issue, don't have a uniform grind, or the tension is too loose.